Dear students, in today's session, we are going to see the remaining two equations of motion. In the previous class, we have discussed first equation of motion, that is V is equal to U plus AT. Look at this graph. Already we have discussed OA is initial velocity and BC is final velocity, OC is T, that is time. Then the change in velocity is acceleration, that is V minus U by T. Okay, how can we calculate the distance traveled with the help of the graph? The distance traveled with the help of the graph is the area enclosed within OABC. It is looking like a trapezium OABC, but it is the combination of a triangle and a rectangle. So area of the triangle and area of the rectangle OADC. You know the area of the triangle formula as well as the area of the rectangle formula. That's why it is written OA into OC plus half into AD plus BD. You know very well OA is U, BD is equal to AT. Already we have seen in the first equation of motion. So OA into OC is the length and breadth of the rectangle. After substituting in the equation, so U into T plus half into T into AT. So in the next equation we have written that is UT plus half AT square. This is called second equations of motion. Here S is distance travel, U is initial velocity. The third equation of motion, let us see now. Once again, we can consider the trapezium OABC. Here, the area of the trapezium is equal to the distance travel. So, the formula for area of the trapezium is the addition of two sides into base divided by 2. Am I right? So, we can write that S is equal to area of the trapezium is OABC. You can write it as now S is equal to OA plus BC into OC divided by 2. You know very well OA is U, BC is V, OC is T. So here we are substituting that in this equation. So what will we get it? So S is equal to OA is U, BC is V, so U plus V into T by 2. That's what we are going to substitute it here. Okay, now once again from this equation we can find out T. So T we can calculate from the formula of acceleration A. You know very well A is equal to V minus U. So, in the next step, you can write A is equal to V minus U by T. So, T is equal to V minus U by A. You can substitute the value of T in that equation. So, S is equal to V plus U. In the place of T, we have substituted V minus U. Again, 2A. So, S is equal to A plus B, A minus B formula it is look like. So, B square minus U squared by 2A. You can bring 2A this side. So, 2AS is equal to V square minus U squared. This is called third equations of motion. Here A is acceleration, S is distance covered. So, dear ones, the first equation is second, third equations are here. Dear student, now we can see a problem based on the formula of the equations of motion. A motor boat starting from rest on a lake accelerates at a rate of 3 meters per second square for 8 seconds. How far does the boat travel? Given data have written. So time is 8 seconds. Acceleration is given 3 meter per second square and it starts from rest. So initial velocity u is 0 and they have asked to find out distance, that means s. So which formula we can choose for it? We can't choose the first one because it is asked to calculate s. And second and third we can choose. I have chosen second one, that is s is equal to ut plus half at square. Here u is 0, so 0 into 8, that means time is 8 seconds, 8 plus half, acceleration is 3 and t is 8 into 8. Then cancellation has taken place. So 3 into 4 is 12 into 8. Here 0 into 8 is 0. So that's why 0 plus 12 into 18. Then I have multiplied 12 with 8. Now the answer is 96. So the distance traveled by the boat is equal to 96 meters. Hope you understood this problem.